just half AB sine C, okay? So use it when you have two sides and an angle in between, rather a perpendicular height, you can find the area of the triangle. First, we're going to find the area of this triangle given. So what you do is you go, area is half times 12 times 16 times sine of 60. Correct to two decimal places, so you can do that on a calculator. So you go 12, which is 6 times 16, because I half the 12, then times by sine 60, and sine, oh, I'm in the wrong mode, just be careful, I was teaching you 12, and in radian mode, should be in degree mode, see it's D now, equal, okay, works, 83.13, 14. Two decimal places, square meters. Any questions? Can you try the next one? Give you a minute, you should be able to work out very easily without thinking. All good? Have your calculator with you. If you don't have your calculator, come to the front and borrow one. You need to use a calculator in this topic. All right. All done? Okay, good. Let's try the next one. Going to ask Jeremy, so what do you do to find area? Perfect. Okay, good. All right, let's work out. Christina, what did you get? All right, anyone got different? All right, she got it right. Okay, good. Okay, any questions? Very easy. Now we're going to prove some formulas. Now the proof is not examinable, but I'll just prove it so that you know where all these formula come from. The teacher might have proved it in year 10, but we're going to prove it now again, or the first time you see it. All right, the proof is not examinable, but it's good to learn some. Okay, not examinable. The main thing is need to know how to use the formula. We're first going to prove the area formula because that's easy. Area of triangle. So what I'm going to do is to draw this triangle over here. We got B, got the A, got the C, right? Right, C. So what we're going to do, we're going to find the perpendicular height. Let's call that H, right? So what you do is, to find the area is half times base times H, right? And the question is, can we find H in terms of the angle and A? Yes, we can. So we're going to go in this triangle, actually in here, in this triangle we can write sine C. What's sine C equal to? Opposite over hypotenuse. Which one's opposite? H over A, yes. And then what we're going to do, let's make H the subject. What's height equal to? H equal to A sine C, isn't it? So I could now replace the H by A sine C. Right, the H you saw in the area triangle, half BH, that H is A sine C. So half B, which is half AB sine C. So it's not very hard. But it's good algebraic skills, okay? It's good to learn, look at this proof, you improve your mathematical thinking. Okay, we did the area of the triangle. Let's do the sine rule. And there's a reason why I do this first, because that actually helps you to prove the sine rule very easily, which we'll see in a minute. Of course, there are different ways to prove the sine rule, but I like this way. Okay, now, let's prove of sine rule. Okay, proof of sine rule. How do I prove the sine rule? Very easy again. Okay, all right, let's do this. We're going to look at this triangle again. We've got A, B, and then C. That's a capital C for vertex, capital A, and capital B. We're going to find the area of the triangle in 3 different ways, using 3 different angles. So let's find the area of the triangle. Area equal to half AB sine C. Or area is also, if I use angle, say B, it's going to be sine B, but which 2 sides will we use? A and C, right? A and C, right? That's also the same area, isn't it? Area of this triangle using two different sides. I could also find the area using these two sides, which is A, sine A, which involves sides B and C, isn't it? Alright, now we can make them all equal. Let's see what happens if we make them all equal. Okay, so let's make them all equal to each other. They're all the same. That's the key point. So let's write it down. Half BC sine A, we'll go in alphabetical order in terms of angle. Half AC sine B equal to half AB sine C. And then let's get rid of the half, right? Times by 2, times 2, times 2, that will cancel. So you end up getting BC sine A equal to AC sine B equal to AB sine C. Right, we'll go rid of half. And the next question, how do I get rid of A or these things in front? Okay, all you have to do is to divide by ABC, ABC, ABC. Let's see what happens. The B and C get cancelled. This one, the A and C get cancelled. This one, you get A and B get cancelled. And what we left with? We get the sine A over A equal to sine B over B equal to sine C over C. I like this proof because it's very easy to learn. Because areas are the same, right? Using different sides. That's the sine rule. Alright, okay, any question? We're not going to prove the cosine rule. We can, but it will take a bit longer. Cosine rules are a bit hard to prove. If you're really interested, you can look at the textbook. They will show you how it's proved. But we're not going to get into that. Yeah, because it's confusing. Okay, alright, let's move on to summary. Okay, so we've done some proof. We're going to do a summary. Alright, yeah, there's actually some space for proving cosine rule, but you just maybe look at it yourself. Okay, okay, let's look at a summary. Summary of applied trigonometry. So we've got formulas for the area of the triangle, half AB sine C. Another formula for the area of the triangle is half BH. So let's look at these triangles. What formula do you use? If you got the perpendicular height, it's better to use half BH. So be careful, do not forget your old formula because they are still useful. So if you do that, you go half times 8 times 6, you get 24. And the formula also works for this triangle, half BH. You go half times 6 times 8, which is also 24. I think they're all 24, isn't it? Because they are all perpendicular height. The height is given. So you get half times 6 times 8, which is 24 again. Now, because there's an angle, you can also use the sine rule to do that. You can just do half AB sine C, right? Or you can just go half 6 times 6 times 8, sine 90, right? You can use this formula, but it's longer, isn't it? Now, what's sine 90? Do you remember? What's sine 90? Sine 90 is exactly 1. So it's actually become BH, isn't it? Right? So just get 24. But you're not going to use that. That's quicker, isn't it? Rather than use the sine rule. However, this will have no choice. You have to do half times 6 times 8, sine 117, because no height is given. So in all the three previous cases, there's a height, perpendicular height. But in the fourth case, there's no perpendicular height, so you have to use this formula. And the answer won't be 24, will be less than 24. Yep. Yep. Yep, let me put. Okay, now, you use the sine rule to work out this area, so just be careful. Sometimes use the half BH, sine of the angles. No, sometimes use the half base times height. The other one is to use half AB sine C. So we do this 6 times 8 times sine 117. Okay, so you get 21.38. Just 21.4. Okay, 21.4. Approximately 21.4. Okay, now you know the differences and the similarity between them. Now go to the next page, or the last page of the summary. Okay, we've got these formulas, sine rule, cosine rule. Now, they only give you the sine version on the reference sheet. They do not give you these two, so you have to memorize them, okay? So remember, when do we use the cosine rule where all three sides? Oh, okay, sorry. That should be SAS. When you have sine, angle, side, this should be all sides given. Oops. How can that happen? All right. SSS, SAS. Okay, good. I'll update it for future edition. Okay, let's find things on this page. Find the value of polynomial. So obviously in the exam, they do not give you any, they don't give you any clue what formula to use. So you need to know what formula to use. So let's look at the first one. What rule should we use for this triangle? Cosine. How do we know? Why? Sine, angle, sine, you can find C. Perfect. Let's do that. C squared equal to 6 squared plus 8 squared minus 2 times 6 times 8 equals 117. Okay, good. Do that, and then you just do it on a calculator. You get the answer. So you get 6 squared plus 8 squared minus 2 times 6 times 8 equals 117. Good. 143. But remember to 143 ... Remember to square root your answer to get the answer. Okay, so we're just going to go square root answer. You get 11.98. Right. Good. So you get that. Now, what rule do we use for the next one? Pythagoras. So you don't need the cosine because it's a right angle. So you just go c squared equal to 6 squared plus 8 squared. Now, what if you use the cosine rule? Would it give you the same answer? Well, you will, but let's see what happens. Now, you got the extra 6 and 8. Cos 90. What's cos 90? Cos 90 is 0, isn't it? So that's why this just disappears, becomes the Pythagoras theorem. Okay? You can use it, but can you see why it still works? Because cos 90 is 0. So if you do cos 90, you get 0. And what happened with 0? What happened to the 2 times 6 times 8? It becomes 0, isn't it? So it ends up with this anyway. But you're doing extra work when you use the cosine rule. You might as well use the Pythagoras theorem. Okay? So let's do that. So you go 6 squared plus 8 squared. Use a calculator. You should get 10, right? If you remember your Pythagorean triad. Okay, so remember when to use cosine rule, when to use Pythagoras theorem. Okay, not to overlook your old formulas. They are still as useful before as it is today. All right, let's do the next one. What rule do we use for the next one? Yeah, because it's not SAS, it's not SSS, so it must be sine rule. So you go A over sine 30 equal to 11 over sine 104. 40. Okay, and then you just find out what A is, and then you just go, what do I, okay, so you go 5.5 times divided by sine 140. Okay, good, 8.56. Yeah, okay, good, any questions? All good to say? Oh, oops, 104. 04. 5.67. Okay, 5.67. 5.67. I need to update this one. Okay, how about the next one? What rule do you use? You use the SOHCAHTOA because it's a right angle. You can use the sine rule, but you get the same answer, but it's longer. It's quicker if you just go A over 11 equal to sine 34. Right? Don't use the sine rule because it's longer. So you can see it's much quicker rather than putting extra sine 90 somewhere, and sine 90 is 1. Okay, good. So you just do that on a calculator. 11 sine 34 equals 6.15. Okay, so remember not to overlook your old formulas. They are useful. Okay, what do I do next? We're going to do the next one. What rule do we use? Sine rule. Well done. Okay, so now you should be confident what rule to use because it's very easy to identify. It's either SAS or SSS for cosine. Everything else must be sine rule. Or SOHCAHTOA if it's a right angle triangle. Okay, so we're going to go 12 times sine 27, close bracket divide by 6. You get 0.907. Remember, this is not an angle, this is a ratio. And to find the angle, what do? You have to go like this. Shift sign, answer. Now, there's a problem with the answer. What's the problem with that one? Does it match the diagram? Now it's a obtuse angle. So what do you do when it's obtuse with sine rule? You have to do the extra step of 180 minus the related angle. Right, so what you should do is go up, press equal again, go back, 180, 180 minus your answer, 114 degrees, or approximately 115 degrees. Okay, to the nearest degree. Right, so be careful, when it's obtuse, you have to do that extra step when it's obtuse. Obtuse. Alright, what rule do we use for the next one? Cosine, because SSS, cosine. Now with cosine rule, you don't have such a problem because cos theta, you get 6 squared plus 8 squared minus 12 squared. Ooh. No, it works. Does it work? 6 plus 8. Yeah, it works. Okay, good. 2 times 6 times 8, and then use your calculator. So you go 6 squared plus 8 squared minus 12 squared equal divided by 2 times 6 times 8. So equal, okay, you get negative 11 over 14. Negative 11 over 24. When it's a negative, you know it's going to be in the second quadrant, isn't it? By all stations to central. So theta is cos inverse. Just do that on a calculator. You don't need to find the related angle. It will automatically give you an obtuse angle. So shift, cos, answer. So different from sine rule, you have to do that extra step of 180 minus. But with cosine rule, you don't have to worry about that. It gives you the answer that you want. So just be careful with the sine rule, but cosine rule covers everything. Alright, good. Approximately 117 degrees. All good. Okay, once we are done, what do? We have to get you to do the work. So today's work is up to 6.13 now? 6.13 today. Good. Alright, start now. And you can do the chapter review if you haven't done so.